Hi again, everybody. So this is the second of a 3-lesson series on symmetry. And in this lesson, we're going to be discussing symmetry with respect to a point. So just like in the previous lesson where we talked about symmetry with respect to a line, we're going to start with kind of a basic understanding of what it means to be symmetric with respect to a point. So you'll notice that I drew a pair of coordinate axes, x, y, and then I labeled a point 2, 3. The significance of the point isn't anything. I just picked a point and labeled it. So what I'm going to do now is I'm going to draw half of my graph. So I'm going to pick some color, and then we're going to go maybe up like that, and maybe down like this, and then up again from there. Okay, so I tried to be kind of careful to do it through a few nice points so that like we could get a better idea of shape. So what I'm going to do, and I hope that this feels familiar given what we did with the previous lesson, symmetry with respect to a line, is I'm going to pick a few points on what I just drew. Right, so I'm going to pick these 3 because they're pretty nice. And one by one, so I'm going to start with this one. Okay, I'm going to dot down to 2, 3. There I am. And then I'm going to keep on going through that until I get exactly the same distance away. So part of the reason this point was nice is that I know that I had to go down 2 and over 3. So in my head, I was kind of measuring, okay, you're going down 2 over 3, and that's where we're going to stop. Okay, by that same token, let's do this point here. So you'll notice that, again, it's a nice point. So I can clearly see that I'm going down 1 and over 2. So I'm going to do the same thing there. Down 1 over 2. So there is that point. And then finally for this one, I'm going down 2 over 1. So that takes me here. Okay, so now that I have kind of that general shape sketched out, I can draw in the graph. So it goes down to here, up to here, and then down like that, right? So if we kind of smooth it through there, we see the shape. So that is what symmetry with respect to a point looks like. And we can have symmetry with respect to any point at all. But for our purposes, we're going to focus on symmetry with respect to a very special point. So for our purposes, we will focus on symmetry with respect to the origin. Okay. So, of course, the origin is a point. Its coordinates are 0, 0. Now, again, you really could talk about symmetry with respect to any point. So if you're kind of curious, you could think about how would you describe symmetry with respect to any point, similarly to the way that we're going to describe symmetry with respect to the origin. But that's something for you to think about outside of this lesson. It could be a really great way to sort of engage with the material more in your own time. If you're curious, feel free to post a discussion about it, and I'm happy to talk more with you. But I do want to make one little observation before we move on. Note, to be symmetric about a point, the graph has to pass through it. Okay, so if somebody asks you, hey, is this graph symmetric about the point 2, 3? And you see it doesn't even pass through the point 2, 3, the answer is definitely no. So that's kind of a handy little thing to remember off the top of your head as just like a real quick baseline. Okay, so now let's move on to talking about symmetry with respect to the origin. So down here, I've got a graph, okay, and this is some function that I don't really care what it is, but it's some function that is symmetric about the origin, right? So I'm going to kind of write that here to have it as a guiding principle. So this graph is symmetric. You scroll over a little bit to have a little more room. Symmetric about the origin. Okay. All right, and I want you to sort of observe a few things. So much like I did in the symmetry example for the symmetry with respect to a line, I'm going to just do a few points here. So here's a point up here. So it kind of looks like, and again, I don't really know what this function is, but this point that I just labeled looks like the point -1, 3. And I'm going to do the same thing I did in the last lesson and also in the example just a few seconds ago. I'm going to dot through the origin until I get down to a point on the graph that's on the other side. And if you look at the coordinates of this point, oh, it looks like its x-coordinate is +1 and its y-coordinate is -3. So it looks like both of the coordinates switch signs. Let's try another point. So we'll pick this lovely red color. And for this one, I'll pick this point here. And again, I don't really know what this function is. I'm just going to call the coordinates of this point AB. And I'm going to do the same thing. Right, so I'm going to go down to the origin and then on over until I get to the analogous point, or to the partner point, you could almost call it, on the other side. So again, I don't really know what A and B were, but clearly the point that I just drew, its x-coordinate is the opposite of what it used to be when we started, and the y-coordinate is also the opposite. Okay, and then I'm going to do one last one. So let's do this one in this nice green color. So I'm going to pick a point up here. Okay, and I'm going to just say that its x-coordinate is x and its y-coordinate is f of x, because again, we're talking about this in the sense of function, so I really want you to keep thinking about the fact that every point on the graph of a function is an input-output pair. So same thing, there I go. I'm going to dot down to the origin, and then I'm going to keep on going until I get down to here. Okay, and so again, you can see it looks pretty believable that the x and y coordinates are opposites of what they were when they started. So the x coordinate is -x and the y coordinate is -f of x. So you know me, from the beginning when we started talking about functions, I've been saying that I want everything we say about functions to be in the language of inputs and outputs. So I'm going to write it here to the right. The output that f assigns to x is the opposite of the output that f assigns to -x. Okay? In other words, the y-coordinate of the point whose x-coordinate is x is the opposite of the y-coordinate of the point whose x-coordinate is -x. So both of the signs switch. In other words, f of -x is the opposite of f of x. Okay? Before I finish this lesson, I just want to say one last thing, which is that if you remember in the first lesson we looked at, we said that functions that are symmetric with respect to the y-axis are also called even functions. Well, there's a similar name here Functions that are symmetric about the origin are called odd. So this concludes just sort of an overview basic introduction of what it means to be symmetric about a line, symmetric about a point, what it means to be odd, what it means to be even. And in the next video, I'm going to go through a few examples to show you how you would test. If you're given a function without its graph, so you're not looking at a graph, how do you tell if it's odd or even or most likely neither? All right, keep watching this lesson for more.